Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here. In my previous video, I have explained first law and second law. In this video, I will explain third law of the logarithm, which is that if any number has some exponent, so this exponent will be written in the start of that number in the logarithmic form. Okay. So how we will prove this one? In the book, it's written in a little bit confusing form, which the students are not understanding easily. So most of the time I'm saying that just take this number and take this proof easily as you are doing the proof of the law number 1 and law number 2, that let a log of am is equal to x. Okay, write it in the exponential form. Ax will be equals to m. Okay, after this taking an exponent on both sides. Both sides. So when I am taking exponent here also and on this side also, this exponent and exponent will multiply to each other, whether you write nx or you write xn, but alphabetically we write nx, m power n. Okay, a with nx and this is m power n, because if the number is single, its exponent will be written like this, but if the number already have a power, so power and power will multiply to each other. From here, change it in the logarithm form again. Before changing in the logarithm form, you must check properly that these two complete numbers will exchange with each other. Base will remain same place and mn will come here and nx will be written here. When you're writing in this one form, so your formula or your law is already proved that n, replace the value of x, which is here log of m with base a. So it is proved very easily that take the same value, this one value as with the base as x, write in the normal exponential form, take the power n, solve it, take again the logarithmic form, and it is completely solved in this way. Next I will explain the fourth law of logarithm. Yeah, this is the fourth law of logarithm and this is called the change of base formula also. Log of a means base is here and exponent is here. Mostly I teach the students in this way, that base is here, exponent is here. You can include one number. If you want to include one number over here, one, like if you can multiply and divide, you can add or subtract. So in the log form, if you want to add that number, so you have to take that number as the number and the base in the multiplication form. Okay, you can include that number for your solution like in this form. So for solving this one, we will take this number as x for proof. Let log of b n is equals to x, such that when you are changing it in the exponential form, bx will equals to n. Now taking log with base a on both sides. We are not changing this from the exponential form to log form. We are writing log a, or we are taking log with the base a on both sides. This is the different steps which we are doing in this theorem only. Log a on this number bx and log a on this number n. We know from the previous law, when any number with the base is already having an exponent, that exponent will come in the start and it will be written in the start. Log a b is equals to log a n. Replace the value of x over here. What we have taken, it is log bn. So log bn multiply by log a b is equals to log of a n. So like this it is completely solved, means it is proved this side. Log an equal to log of bn into log of ab. So it can be changed to this side also. It can be changed to this formation also. Now changing in this formation. See, they are keeping this in the numerator. They are keeping this in the numerator. They are shifting this down in the denominator. When they are shifting this down in the denominator, means when they are keeping it as it is in the numerator, but when they are shifting it down in the denominator, it will change to log. Base and number will be changed with each other. BA. Now, how this will happen? We have to prove this relationship, that when a number with the log is taken to the denominator, its number and base will change each other. Like any number, if taken from the numerator to denominator, its exponent will change its sign. Okay, same is in the log form also. When the log is shifted from the numerator to denominator or denominator to numerator, the number will change its place from its base number. We have to prove this one relationship, and in this video I will continue to prove this one relationship. We have this proof, so put n is equal to a in equation number 1. So replace n with a, it will become log b a into log AB is equals to log AA. Now we have this relationship. I need to write this up. We know about this one fact, that log of any number with the same number base will change to 1. This is equals to 1. So it means that this number will be equals to 1. So it taking the form of 1. So this will be equals to 1 over log AB. Yeah. So this will be equals to this one. So in our upper formation, as we have proved like this one, as I proved like this one, so in my this one expression, log of AB, so from equation 1, log Bn into, instead of this one, I can write this, or instead of this one I can explain this, means this one, or log of AB equals to 1 over log of BA. So I can replace anyone according to my requirement in this one, because this is being shifted, so I will use this value of this, that is 1 over log BA equals to log of AN. So hence it is changing into the formation of log of Bn over log of BA equals to log of AN. Hopefully you will understand. Let me explain this again. Complete. This is the fourth law for the change of the base formula. I take this one value as x, write in the exponential form, taking the log A as the base, or taking log A on both sides. When I take log A on both sides, its exponent will come in the start, or it will multiply in the start. When it is done like this one, I replace the value of x, and my first part of the theorem is solved. For the solution of the second part, this one part, I need to write this one. I need to find out this one. For this one, what I have done, in the same form 1, I replace n by a. When I replace n by a in this one equation, it become BA into log AB is equal to log AA. This value is equals to 1. Its value is equals to 1. So when I replace this value equal to 1, it become equal to this one. Now log BA can be equal to 1 over this one, or log AB equals to 1 over this one. Means this is equal to 1 over this value, or this value equals to 1 over this value. Anyone you can use. In your given law, this one is being replaced, so I will use this value. Use this replacement in this one. I write equation 1 will be changed to log of Bn into the value of this one equal to log n, and this multiply by 1 equal to this one, and that's how our second part of the law is also proved. This is the first part of the law, and this is the second part of the law which is being proved over here. Hopefully you will understand nicely, and it helps you a lot. Thank you so much. Allah Hafiz.